Alright, this is the second part of the post-test study guide. We're going to start at number 23. Remember to use your hint sheet. Remember to show we work on every single problem. Remember, I'm going to grade the green packet just like I graded the gold packet. I'm going to collect it while you're taking the post-test. I'm going to grade those. Not entirely on accuracy, but I will go through and see if you're attempting every problem, and your grade out of 30 points will be based on that. So don't skip problems. Don't skip steps. Show all your work. Alright, number 23, it says simplify the cube root of 24. So because that's a 3, we're going to use perfect cubes. So I know 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. So I gotta hope something goes into it. What I find out is 8 goes into 24. So I'm going to rewrite 24 as 8 times 3. 8 is not allowed to leave, or is allowed to leave the jail, because he's perfect. He's 2 cubed. So he gets to leave jail as long as he gives up his little 3. So he gets to leave. This guy stays in forever because he's not an exponent. You're only allowed to cancel out with that 3 if you're an exponent. So it's the 2 cube roots of 3, and that's it. Alright, 24. I have the cube root of x to the 6th, y to the 30th. Alright, there's a long way and a short way to do this. The long way is, if you want, you could take x to the 6th. I can write it as x cubed and x cubed, because that's still 6 x's. And I can write y to the 30th, y cubed, that's 1, y cubed, that's the second y cubed. There's a third y cubed. Here's a fourth y cubed. Here's a fifth y cubed. Here's a sixth y cubed. Here's a seventh y cubed. Here's an eighth y cubed. Here's a ninth y cubed. Here's a 10th y cubed. That's a really long way to write 1030s. But now you can physically see who's allowed to leave. How many x's are allowed to leave jail? 2, because they both have little 3's to get out. So like we said, remember this is a jail. The only way you can get out of jail is if you have the little 3. X gets to leave. Another x gets to leave. So you have x times x outside of jail. All 10 of these y's get to leave. There's 5, there's a 6y, there's a 7th y, 8th y, 9th y, 10th y. Now that's way too long, so just write it as x squared y to the 10th, and that's your final answer. Shortcut, 6 divided by 3 is 2, that's why it's x squared. 30 divided by 3 is 10, that's why it's y to the 10th. So you could use that to skip all this work. Alright, that's it for 24. Alright, 25. I have negative 1/2 cube roots of 10 plus 3/2 cube roots of 10. This should be a 4 out of 4 problem for everybody, because if the radicals are exactly the same, all you do is you add 3/2 and negative 1/2 together. That's 2 over 2. The radical doesn't change, just like when you combine variables, they don't change. 2 over 2 is just 1, so your final answer, cube root of 10. That's it. 1 cube root of 10. If you want to put a 1 there, I'll take that for full credit, but you don't need it. And that's it for 25. Alright, 26, a little bit different because the radicals don't match. So I gotta hope I can make them match. So I know I'm going to use perfect cube, so I gotta use that perfect cube list. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, and now those are all bigger, so I don't need any more. Now what I find out is that 64 goes into 128. So remember, we started at the bottom, we listened to Drake. Drake tells us to start at the bottom. 128 would fit right here. 125 doesn't go into 128, but 64 does. 64 times 2. So 64 is perfect. He gets to, so I'm going to rewrite this as 3 cube roots of 4 cubed times 2. 4 gets to leave jail, so he's got to give up that little 3 to leave jail. 4 times 3 is 12, that's why it's 12 cube roots of 2. Now, same thing here. I look at 432. 432 would fit on my list right here. 343 doesn't help us. But 216 does, because it's 216 times 2. 216 is perfect, so they get to leave jail, so I'm going to rewrite it as minus 1 cube roots of 6 cubed. That's why the 6 is allowed to leave jail. Times 2. 2 has to stay in forever because he's not perfect. So 6 gets to leave. That's why it's minus 6 cube roots of 2. Now my radicals match, so I do 12 minus 6 to get 6. And then the cube root of 2 just stays there. And that's it for 26. Alright, 27. They give you an f of x, they give you g of x, they tell you to do g of f of x. Remember, that's a composition. We've done this before, which is recent from the last quiz. So I see what's written first, g. That's when I say g of blank space. So g of blank space kind of looks like g of x. That's why I write 3 blank space squared. I leave this line alone. Don't change this line. Just start a new line. So you can always have this to look back at. And plus, that tells me you know how to do the first step, which is going to give you 2 out of 4 points. So g of f of x. See how I plug in f of x inside the blank parentheses? So on the left side, I put f of x. On the right side, I put x squared minus 5. Because look, on the left side of this is f of x. On the right side is x squared minus 5. So I have 3x squared minus 5 all squared. Okay. Somebody's going to try and distribute this little 2 to both the x squared and the 5. You can't do that because there's a minus sign in between. So you have to rewrite it as 3x squared minus 5, x squared minus 5. I FOIL, or distributive property, x squared times x squared is x, so I have 3x to the 4th minus 5x squared. Inside is minus 5x squared plus 25. So now I distribute that 3, so my final answer is 3x to the 4th. I'm going to combine those before I multiply by 3. That's minus 10 times 3 is minus 30. X squared plus 75. And that's it for g of f of x. Alright, 28. They give you f of x and g of x. They say 1 minus x squared and 1 over x. 28 says to find g of negative 1. So I'm going to see what I see first is g, so I put g of blank space. So I do 1 over blank space. And like I said, I'm going to leave this line alone. So I go g over g of negative 1. So I go 1 over, in the blank space, I put 1 over, and instead of x, I put negative 1. All right. Now, if you divide by a fraction, you flip it, everything is all over 1. So my final answer, if you want to put this in your calculator, you would put 1 divided by, in parentheses, 1 divided by negative 1, close the parentheses and hit enter. So you'd end up getting negative 1. So g of negative 1 just turned out to be negative 1 in this case. And that's it. Alright, 29 is very similar to 28. At this time it's f of g of 2. So you're going to want to start with f of blank space. So I'm going to write 1 minus blank space squared. Now, some people like doing this. Some people like going f of g of x. So they put 1 minus 1 over x all squared, because that's f of g of x. And then they write f of g of 2. So they say f of g of 2. They just have a little bit easier time figuring out where the x goes and then where to plug in that 2 afterwards if they do it this way. So I have 1 over 2 squared. I square 1/2. 1/2 squared is 1/4, so I have 1 minus 1/4. So my final answer is f of g of 2 all equal to 3/4. And that's it for 29. So I think this page is probably one of the easier pages. This entire 18 to 29 should be a lot of points for everybody. Alright, number 30 says, which of the following is an equation for the inverse of the function f of x equals 2x plus 2/3? So that means you're just going to find your inverse. So you're going to use the find inverse hint. So hopefully you remember you write y instead of f of x. Then you switch. So I have x equals 2y plus 2/3. If you hate fractions because you see this 2/3, multiply everything by 3. Every single thing. So I get 3x equals 6y plus 2. That gets rid of your fractions. Now we just solve for y, subtract 2 from both sides. So I get 3x minus 2 equals 6y. Then I divide by 6. I get y is equal to 3x minus 2 all over 6. Step 3 says write inverse function. So you're going to put 3x minus 2 all over 6. I would take that for full credit, except it's a multiple choice and that's not one of our answers. So you're going to want to break this 6 up. So your other option would be 3 over 6 x minus 2 over 6, which would be f inverse of x equals 1/2 x minus 1/3. And that's it for 30. 31. We're once again finding the inverse. F of x equals x to the 4th. So step 1, y is equal to x to the 4th. Remember, that's a restriction. I say that for the end. I switch x and y, so x is equal to y to the 4th. I use PEMDAS backwards. So how do I get rid of an exponent? I take the 4th root of both sides. Now remember, that's even. So when I get y equals plus or minus the 4th root of x. Last thing I have to do, I'm going to rewrite it as f inverse of x. And because the restriction is bigger than 0, that means positive. So I don't include the negative, I just put the 4th root of x. And that's it for 31. 32, exact same concept. So we're finding the inverse. Hopefully now you know what to do. You say, I'm going to write y instead of f of x, x cubed minus 2. I'm going to switch them. This is all on the hint sheet. I'm going to solve for y. So I'm going to add 2. I'm doing PEMDAS backwards in case you're not sure. I got rid of the subtraction with addition because remember they undo each other. I have x plus 2. Somebody's going to write 2x here. Remember, x plus 2, they are not like terms, so you cannot turn that addition into multiplication. So it's x plus 2 equals y cubed. Now how do I get rid? There is no addition, there is no division, there's no multiplication. I see an exponent. I get rid of that with a check mark. Remember, it's got to have a little 3 there. And if I do this on one side, on the quizzes, I saw a lot of people take the check mark on one side, but they didn't put it on the other. So the check mark's got to show up on both sides. Luckily, with the y, it cancels, so I get y is equal to the cube root of x plus 2. So then I finish up and I write inverse notation because I'm saying this is an inverse, is the cube root of x plus 2. And that's it for 32. Alright, 33 says verify or prove. Remember, that's like we're going to court. When you go to court, everything's got to look nice. You got to submit all your evidence. So you have to show all your steps on these. So 33 says, I have f of x as 1/3 x minus 1/2. G of x equals 3/2 2x plus 1. Alright, so part 1 is we've got to do f of g of x and see if it turns into x. If that happens, there's a chance there's inverses. So once again, I do everything like we did before, f of blank space. So I do 1/3 blank space minus 1/2. So I just got that from right there. Now, I put in g of x in that parentheses. Notice I left that blank space line alone. I don't want to change that. All right, I'm going to use that to make sure I didn't forget anything. So I do 1/3, and then I put all this inside these parentheses. So I put 3/2 times 2x plus 1 minus 1/2. I'm going to distribute the 3/2 first. So I end up with 1/3. 3/2 times 2 is just 3x plus 3/2, all minus 1/2. Distribute this 1/3 now. It turns into x plus 1/3 times 3/2 is 1/2. And then it's minus 1/2 because that drops down. Those cancel. So it does turn to x. So I'm halfway there. So remember, there's two sides to every story, so I got to see if g of f of x turns into x. So I do g of blank space. So I do 3/2, 2, and I put a blank space, plus 1. So when I put in f of x, it's 3/2. 3/2, 2. I put 1/3 x minus 1/2. See, that's in the parentheses. And then there's the plus 1, and I close that. So that's one of the reasons I keep this blank space here, so I can compare. Look, I have 3/2. I have my 2. I have my plus 1. So I didn't forget anything because the only new stuff is that empty parentheses. Now I'm going to distribute this 2 to start, so I end up with 3/2, 2/3 x minus 1 plus 1. The 1's cancel, so I'm left with 3/2 times 2/3 x, which is just x. So just like I thought. So the last thing you got to do, guys, on 33, don't forget, is you have to say, since f of g of x equals x, and g of f of x also equals x, they are inverses. And that's it. So here's all the work. Did all this work. These are all the proofs. All right. I have my label. You probably should put your label in throughout the whole way for every single time. And then don't forget this line. Somebody's going to forget this line. This line's important. All right. Don't forget it. And that's it for 33. All right. 34. Same exact concept. So I'm going to start with f of g of x, and I'm going to find out. That's why I put a question mark there, because I don't know if it's true. Does f of g of x turn into x? So I'd start with f of blank space. So I put 2/3 blank space minus 1/2. Then I plug in g of x. So I put 2/3 blank space. Instead of the blank space, I put 3/2 x minus 3/4, all minus 1/2. I distribute the 2/3. I end up with x minus 2/3 times 3/4. The 3's cancel, so I get minus 1/2, minus 1/2. Somebody here is going to think these cancel, but those don't cancel. So you say, since f of g of x does not equal x, they are not inverses. So you don't have to do any more work, because it did not work out like we wanted it to. All right? That's it for 34. All right, number 35 says sketch the graph of the function. Determine whether the inverse is a function. So the first thing we're going to do is we're going to make an XY chart. I'm going to pick -2, -1, 0, 1, and 2. I'm going to plug them in. -2 times -2 is +4. 2 plus 4 is 6. -1 gives me +2 and 2, that's 4. 0 gives me +2. 1 gives me 0. 2 gives me -2. So I'm just graphing that. -1, or I got 0, 2. So now I'm going to connect the dots. Alright, here's my line. So, since f of x passes the horizontal line test, the inverse. Now a lot of people think they want to say, oh, the function is an inverse. No, it's automatically an inverse, because all you have to do is rotate it and it turns into an inverse. But the inverse is a function. So you have to say it just like that. Do not say it's a function or it's an inverse function. No, you're saying the inverse is a function. All right? So that's what you need for 35. And that's it. All right, 36. So sketch the graph of the function f of x equals 2 minus x plus the square root of x plus 1. So remember, when we graph square roots, all right, if you're not sure what to do, you're just going to pick some points. All right? Maybe you pick -2, -1, 0, 1, and 2. There's nothing wrong with that. 1, I'm not going to like all those points. I'm going to like -1. I'm going to like 0. I'm going to want to pick 3. And I'm going to want to pick 8. And I'll show you why in a second. All right? So these are the points that I'm adding. The -1, 0, 3, and 8. You might be able to get close to this when you graph it with -2, -1, 0, 1, and 2. So here's what happens. When you plug in -2, you get domain error, because you can't have a negative inside the radical. -2 will not work. -1, I get 2, because I get 2 minus 0. That's how I get 2. So I go -1, I go up to 2. That's going to be the start of my graph. Now inside there, I want perfect squares. So I'm going to put 0, because 0 plus 1 is 1. 1's a perfect square. So that's why I like 1. So I put 0 in here. I get 2 minus square root of 0 plus 1, which is 2 minus 1, which is just 1. So I have 2, 0, I have 0, 1. Oh, there's a dot. Now, I don't want to pick 1, because 1's going to get messy, and 1's going to become the square root of 2. You could do that, though, if you want. You wanted to go ahead and get that. 2 minus, you could do 1 plus 1, the square root, so you're going to have 2 minus the square root of 2. It's going to be a messy number. But you could pick it. I'm not going to pick it, because I'm doing this in my head. 2, once again, is going to give me 3 inside this radical, not a perfect square. So when I pick 3, it gives me 2 minus the square root of 3 plus 1. Well, 3 plus 1 is 4. Square root of 4 is 2. 2 minus 2 is 0. So I go over 3. 1, 2, 3, and I stay right at 0. Now I do 8. Why do I do 8? Because 8 plus 1 is 9, and I know 9 is a perfect square. So I do 2 minus 8 plus 1 is 9. Square root of 9 is 3. 2 minus 3 is -1. So I go over 8, down -1. So here's what my graph's going to look like. Notice my graph does not go up. It does not. Somebody's going to make this graph go up. Somebody's going to do this. You can't do that. That's a no-no. Because once you get below -1, if you do -1.1 in your graph, you're going to get domain error. All right? So there's no x values there. That's why we care about domains. That's why we did domain previously. Okay? And that's it for 36. 37, what's the correct graph of the square root of x minus 6. Now, on the post test, it's going to be a little bit easier because I'll have 4 completed graphs for you, and then you're just gonna circle one of them. But if you want to get your partial credit, show me the XY chart. So do the XY chart. That's what I'm going to do right now. So I'm going to make an XY chart, and I'm just going to graph it. So I'm going to put my XY chart here. And I'm going to pick the same thing. I'm going to go through. I see square root, so I'm going to pick perfect squares. So I'm going to pick, and if you want to start off with -2, -1, 0, 1, and 2, that's fine. But I'm going to pick 0, 1, 4, and 9 because that's a square root. And when I plug in -2, I get domain error. When I plug in -1, I get domain error. But when I plug in 0, I get -6. So I would pick these ones right here, 0, 4, and 9. But if you want to pick all the different ones, you can, but they're going to get messy. Like 1. 1's going to work. I would pick 1, 2. The square root of 1 is 1. 1 minus 6 is 5. 2. 2 is going to be messy, so I'm not doing 2 today. If you want to do 2 to start in your calculator, square root of 2 minus 6. I'm going to do 4 because the square root of 4 is 2. 2 minus 6 is -4. It should be -5, by the way. 9 is the square root of 9 is 3. 3 minus 6 is -3. So I just graph it. 0 down to 6. I'm going to go over 1 up to 5. Or down to 5, I mean. I'm going to go over 4. 1, 2, 3, 4. Down to 4. 1, 2, 3, 4. There's my point. And then 9, go over 9. Up, down to 3. See how it makes like a little half curve? And that's it. That's it for 37. Alright, 38 says, find the domain and range of y is equal to the square root of x minus 2. Explain why the domain cannot contain the numbers in the interval 0 is less than x is less than 2. So, I know that since that's an even, normally our domain is all the reals that are positive and 0. But if I plug in 0 here, I get the square root of 0 minus 2. 0 minus 2 is -2. That's not going to work. So really what you have to say is I can't pick anything bigger or anything smaller than 2. So what I'm going to say here, I'm going to say all the positive real numbers, or I'm going to say all the real numbers, but x has to be greater than or equal to 2. If it's smaller than 2, an error shows up. So I'm just saying the domain's all the numbers such that x is greater than or equal to 2. Okay? Now the range is like, let's say you make an XY chart. The domain is all the x values. The range, see why we didn't use R with 2 bars? This is one of the reasons why you have to use R with 2 bars, is because that means all real numbers. This right here means range. Range is what is the location of all the y values. So what I find out, if I plug in pick some numbers, say I pick 2, 3, I'm going to pick 6 because 6 minus 2 is 4, and I'm going to pick 11 because 11 minus 2 is 9. That's going to give me all nice easy numbers in my XY chart. I get 0, I get 1, I get 2, and I get 3. What I find on my range is all positive real numbers, because I'm never going to have a negative number that radical turns into. So that's it. And why can the domain not have a number between 0 and 2? Because that would make the inside negative. So we're going to say because radical would be negative inside. And that's all we're going to get for part 2, so it's up to 38. So that means for Monday, you're going to have the entire period on Monday to work on this. And really, you should only have the last 12 problems to do. So everybody should be doing pretty good. If you have any questions, please let me know. And sorry for not being in class.